video, we will show you how to do the test of compressive strength on a concrete cylinder. But before you start the video, don't forget to check the link in the description below to have a knowledge on how to do the slump test of a concrete.
In order to do the test, we need to prepare the materials first. So, here are the following materials. After having all your materials prepared, we will now do the fabrications of our specimen, which is the concrete cylinder. Place the 6-inch by 12-inch mold in a flat surface and free of vibration, near to the storing place. Second, grease the sides of the mold. Third, fill the mold up to 1/3 of its volume for the first layer. Fourth, strike it with the rod 25 times uniformly across the surface section. Start from the outside, spiraling in towards the center. Fifth, tap the sides of the pot 10 to 15 times to release air pockets and close the tamping rod voids. Next, fill the mold again up to 2/3 of its volume for the second layer and repeat step 4 by penetrating 1 inch into the first layer. Repeat step 5 until the third layer. Next, flatten out the top of the mold. Repeatedly make a zigzag pattern across the top to flatten. Lastly, make sure to clean off the exterior of the mold. After having your specimen prepared, it will undergo curing. The sample has undergone 3 days curing before the actual test. For the curing, initial curing temperature must be 16 to 27 degrees Celsius for at least 24 to 48 hours. Upon completion of initial curing and within 30 minutes after removing the molds, cure the sample with free water maintained on the surfaces at all times at a temperature of 23 ± 2.0 degrees Celsius using water tanks. Compressive strength test. First, remove the concrete specimens from the water tank. Second, place the specimen in the retainer and center it in unbothered cups. Third, align the specimen with the center of thrust of the upper bearing block. Fourth, tilt the rectangular seated block until it is parallel with the top of the specimen. Next, verify that the load indicator is set to 0. Next, apply the load until the indicator stops and the specimen displays a fracture pattern.
Next, we have here a table containing the standard specifications for the compressive strength of cylindrical concrete specimens. For Class A mixture or the 1:2:4 cement sand coarse aggregate ratio, this falls under concrete grade M15. This grade has a minimum compressive strength requirement of 6 megapascals at 3 days, 9.75 megapascals at 7 days, 13.5 megapascals at 14 days, and lastly, 15 megapascals at 28 days. These values were derived based on the strength development characteristics of concrete as explained by Mahajan 2019, wherein it was said that concrete has the ability to gain approximately 16% of its total strength within 1 day, 40% in 3 days, 65% in 7 days, 90% in 14 days, and nearly 99% strength in 28 days. For the calculations, we have here the maximum load of 205,380 newtons, a cross-sectional area of 18,241.47 millimeters squared, compressive strength of 11.26 megapascals, and we get 2 for the ratio of length to diameter. Now for the results and discussion. As for the specimen identification, we have here the Class A. For the diameter, we have here 152.4 millimeters or 6 inch. For the length, we have 304.8 millimeters or 12 inch. As for the ratio of length to diameter, we have here 2. Cross-sectional area of 18,241.47 square millimeters. Maximum load of 205.38 kilonewtons. Compressive strength of 11.26 megapascals. As for the type of failure, we have here type 5 or the side fractures at bottom. For the defects, the specimen displays visible pores upon examination. Submerging it underwater during the curing phase resulted in the formation of tiny bubbles above it. Aside from that, we forgot to tap the outside of the cylinder 10 to 15 times while molding the first layer of the specimen. As a result, cracks formed at the bottom of the cylinder when it was subjected to its maximum load, which can be attributed to the presence of voids in that area due to some errors made during the molding process. As for the age of the specimen, we have here 3 days of curing. For the conclusion, as shown on the table, the minimum compressive strength required for a cylinder made with a Class A mixture and subjected to 3 days of curing is 6 megapascals. Our specimen's compressive strength measures 11.26 megapascals, surpassing the minimum requirement. Therefore, the sample has successfully passed the compressive strength test for concrete cylinders.
So that's it for all the procedures and calculations of the test. Before we end this video, we would like to give you some recommendations. First of all, you need to follow all the steps properly. Make sure that the fabrication of your specimen is also done properly. Otherwise, your sample will have higher chance of failing the test. So that will be all for this video. I hope you learned a lot and thank you for watching!